And here we are with our 6-4 adding and subtracting polynomials notes. So we're going to add and subtract these terms or parts of the polynomials to combine them together. So when we are combining like terms, which is kind of the idea of adding and subtracting polynomials, we add and subtract the coefficients of monomials with the same variables. So again, anything that has the same variable is going to be combined with something else. So for instance, ones that can be combined might be 4x and negative 5x. Again, because they have the same power of the variable, which would be 1. As always, for instance, the number 7 and 8 can go together, right? Make 15. Kind of knew that. Then we have 8mp. So notice there's a combination of variables, but either way, 8mp and 3pm can be put together. Again, because multiplication is commutative, so we could rewrite this as mp, and that would be the same set of variables. Alright, and then the last one, let's see, how about negative 9 t to the third y and 4.5 t to the third y. Alright, so you could combine those together, and if you did, you'd end up with the fact that there are negative 9 of one of them and 4.5 of one, and so there are negative 4.5 t to the thirds y. So just putting them together with that same set of variables. Alright, then those that cannot be combined, for instance, let's say that the leading coefficient is the same. Well, that's lovely, but the variable is not the same. So looking here at x and y, as much as 4 and 4 are alike, we need the variables to be alike, and those were not. And then maybe this next one, 2ab squared and 7a squared b. Okay, so hopefully you can notice in there that a is not squared here, but it is here, and so they are different, especially if you list it out as ABB and this one as AAB. You can hopefully see that those are not the same. And then just to be clear, again, even though the variable is the same, if the power is different, then we can't combine those either. So for instance, another example could be 4x and 4x squared. That can't be combined to be x cubed or anything like that. So, alright, so the next piece here, we're adding and subtracting polynomials. So we're going to, let's see, check to see which things have the same power. And so we have p to the third and p to the third. Those have the same power. And then just a p squared that does not have the same power. So together we will take 12p cubed plus 8p cubed, and then we will tack on 11p squared. So together 12p cubed and 8p cubed is 20p cubed, and then to that we'll add 11p squared, and that is the addition of all of those terms. Alright, the next one here, going from our order, our standard format, we have x squared. From there, there's no x squareds that go with it, so we just have a power of 1 of x. And then the last one there, we have a number with a number. So putting those all together, again, 5x squared minus 3x. Again, neither of those can combine together, but then negative 6 plus 8 do come together. Also being careful with the negative, if it's in front of the term that we're talking about, it needs to stay with the term that we are talking about. Alright, and so putting those last two pieces together, we still have 5x squared, still have negative 3x, but now we're going to have plus 2 to combine them all together. Alright, then we're going to add or subtract these ones, again just because the terms are in between having an addition or a subtraction. So this next one, just as I was doing before, you combine the things that are alike by power. Notice that when I circle them, I do attach that sign to them as well. And so the two higher powers are 2s squared, which should be combined with 3s squared. And so that means that I'm going to have 5 of the s squareds, okay? And then just plus an s, because there are no other s to the power of 1. Alright, then we move on to, let's see, power of 4 is the highest here. So combining those together, we'll have 20z to the 4th. Again, the only thing that changes is the 4 and the 16, and not the power of the variable. And then our second piece of -8 and +2 is going to make -6. Alright, so taking a look at our next piece here, we may have polynomials with parentheses around them. It's going to come into play a little bit more when we talk about subtracting them, okay? But the idea is still the same. Even though they're isolated, we can still basically take away the parentheses and just identify things that have the common power of the variable. Oops, that's a 6. Alright, so putting our common powers together, we've got 4m squared and 1m squared. So there should be 5 of those m squareds. Looking at our next highest power, that's a power of 1, so -m. And then our last is our constants, and those are 5 and 6 to make 11. Same thing happens in the next one. Again, you don't have to take into account these parentheses until you have a subtraction between the two pieces that are grouped. And so if we put them together, let's see, the highest power is this combo. So we have 10xy and -3xy to become 7xy. Then alphabetically, the next piece is going to be x, so we'll add an x to it, and then the last piece there is going to be our y. And since even though those are power of 1, we can't combine them together because they're not the same variable. So we are kind of going through this idea of what can be combined and what cannot be combined. Alright, next piece. Oh my gosh, there are fractions, but that's okay. So again, we're adding between the two, so we don't necessarily need the parentheses. And so now we can go through and find things that have the same power. So a squared and a squared. 1 over 1/2 and then 3/2 makes 4/2. And of course 4/2 is actually 2. So 2a squareds come from those. Then we have 1b to the power of 1 and -4b's to the power of 1. So together there's -3b's. And then that last piece of 2 and 5 for our constants makes 7. Alright, now comes the one where we are subtracting, and so that does change everything behind the subtraction sign, which is why they're grouped in this grouping symbol. So technically this negative sign needs to be put into everything behind it, but not everything that's separated by multiplication, but everything that might be separated into a term. So we distribute that into every term, and there's only one term here, so we only distribute the negative once. So if we take the time to rewrite this, this is going to be x cubed plus 4y minus 2x cubed. Which means that when we're putting our x cubes together, we have 1x cubed and -2x cubed, or to the power of 3, which means we'll have a leftover of -1x cubed, and then plus that 4y, since it doesn't have a partner to combine with. And then our last one, as we were just saying before, that negative, or that subtraction, is going to be distributed into every term after it. And so that means our 7m to the 4th minus 2m squared is going to be combined with negative 5m to the fourth plus, because negative and negative makes positive, 5m squared minus 8. And so if we go through and combine these pieces together, starting at the highest power, we have negative 5 and 7 of the m to the fourth. So that means we have 2 left over, m to the fourth. Then we have a negative 2m squared and a 5m squared. So together, negative 2 and 5 makes positive 3m squared. And then our last constant, or number without a power shown. Alright, so that's your 6-4, adding and subtracting. Really, you just need to be careful with subtracting and make sure that you distribute if there are grouping symbols, aka parentheses.